Today, we will do the impossible. We will fetch real-time cryptocurrency exchange data, as in dynamic transactions that are happening right now and being updated within microseconds. We will then manipulate it, plot it, reconstruct it, and analyze it. And all this without having any prior experience with WebSockets or with fancy servers. So folks, if you're just beginning your data science journey, this tutorial will not only demonstrate a step-by-step workflow, but it will also get you comfortable working with live streaming data. So allow me to introduce you to Deephaven, an extremely powerful open core framework that only recently released many of its features for free. So without any further ado, let's roll. So let's begin by opening our terminal with Ctrl-Alt-T. And as you can already tell, this time I'm using my Kali Linux machine. Now, first things first, we will need to have Java installed on our computer. We won't be coding with Java, we're Python people after all, but we do need to have a Java environment to run Deephaven. For this, we will type sudo apt update, just to make sure we're getting the most recent version of Java, followed by sudo apt install default-jdk, as in Java Development Kit. We can then verify that the installation was successful with java --version. And there you go, we got it. Next, we will need to find the path of our Java environment. For this, we will navigate into our Java shell by typing jshell. And then in the shell, we will type system with a capital S .get property with a capital P, and in a set of round brackets, we will specify the string of java.home. We will then copy the path we got in return, and we can now exit the Java shell with /exit. Okay, now, bye-bye Java, see you later. Then we will create a working environment using venv, which is very surprising because we usually use Anaconda for this. So let's go ahead and type python 3-m venv, and we'll call this environment crypto, which is the equivalent of conda create. Then we will activate it with source crypto /bin/activate. And now the last Java related command is setting our Java home path to the path we just copied. And we will do this with export java_home in all caps, and we will assign it to the path. And beautiful, no more Java. Moving on with Python. Now, just to make sure that our package manager is up to date, we will type pip install --upgrade pip. And once we verify that, we can then go ahead and install Deephaven along with its example app, which we will use throughout this tutorial. So we will type pip install Deephaven -example-app. And once the app is installed, we will run it with python -m deephaven _ not a dash this time, example_app. And once we see that the app runs on port 10,000, we will then navigate to our browser and we will type localhost 10,000/IDE, and boom, we are officially fetching real-time Coinbase cryptocurrency exchange data, just like that, with nearly zero efforts on our end. Now, this is what we call a quick hook. We didn't need to set up a fancy server, we didn't need to deal with WebSockets. Deephaven already figured it out for us. But if we were to handle this on our own, setting it up would have taken way more than just 3 minutes, would probably require a good level of programming experience, or cost us a good amount of money. That's usually the alternative. So those of you who are familiar with this entire process, you're probably shocked. Now, on top of that, we have this really nice IDE, this coding interface and terminal to help us closely explore the data. Now, you've probably noticed that this example app is fetching two different tables. The first one is called matches stats, and it traces the number of transactions, their volume, the average and last prices across both Ethereum and Bitcoin. The next table is called matches table, and it is much more detailed. It traces individual transactions across both coins, and that's the table we'll be working with throughout this tutorial. So let's go ahead and start manipulating this data and adjusting it to our needs. Now, the first thing I notice here is that the type column is quite redundant. It just keeps storing the same string of match time and again in each and every one of our rows, and we don't really need it. So let's get rid of this entire column. For this, we will navigate under the File Explorer tab, and we will click on this new notebook icon. Ooh, let me slightly rearrange the screen so that my head doesn't block most of it. Now, in this new notebook, we will type matches underscore table dot drop underscore columns, which is pretty straightforward. And in a set of round brackets, we will specify the type column. Now, since we don't want to override the original data we're getting directly from the WebSocket, we don't want to mess with that. We will create a new instance of this data by naming this entire expression. We'll just call it my underscore table. Alrighty, now let's save this file. Let's call it crypto.py. And let's give it a quick run, clicking on this run icon. And boom! We have this new tab of my table popping with the type column completely removed. Now, since we have this new instance of our data, we don't really need the old instance of matches table. So let's just close it. And if we ever need to refer back to it, sometimes in the future, we can always find it under the panels section. There you go, matches table. Next, I do like how detailed the transactions are, but I can't say I'm a big fan of combining Bitcoin entries with Ethereum entries on the exact same table, especially since one of them is worth tens of thousands of dollars more than the other. So let's go ahead and split them into two different tables. Now, first we will type my underscore table, followed by the where method, which allows us to filter through rows of interest. And in the case of our Bitcoin data, we are only interested in the rows where the product underscore ID column is equal to BTC-USD. Now let's go ahead and assign this expression to BTC. And we will do the same with our Ethereum data. We'll just copy this line of code. We will paste it below, and we will adjust each instance of BTC to ETH. Now let's save everything and let's give it a run. And beautiful! Now each of our coins has its own special table. Here we can only see Ethereum data, and on our BTC table, only Bitcoin transactions are involved. Now let's say that I don't have much interest in small volume transactions. I really don't care if somebody exchanged a 0.0002% of a Bitcoin. I only care about the major stuff. Now, one way we can solve this is by detecting rows where the transaction size is greater than a certain threshold. So for example, we can go for 0.25, which is roughly $5,000. Now, once we detect those rows, we can then go ahead and change their background color to deep red. For this, we will add an additional method to our Bitcoin table, and we will do this in the next line simply by using the # symbol. Now, the name of this method would be .format_row_where, where the first argument would be the filter we'd like to apply. In our case, we are interested in the rows where the size column is greater than 0.25. Now the next argument would be the color. In our case, we will go for deep_red in all caps, which is a predefined color by Deephaven, but we don't really have to use those. We can just specify a hex value here with hashtag whatever, if you'd like to be extra specific. Now let's go ahead and save everything, and let's give it a quick run. And now we wait for such large transactions to happen. Okay, well, this was lovely, but the only problem is the data is fetched at such a high speed that even if we do detect a bunch of red rows, they disappear almost immediately. Brand new data just keeps pushing them to the bottom. So an alternative solution would be splitting those transactions into their own table. And we already know how to do this. We will simply type btc.where. And in our case, we are interested in the filter of size greater than 0.25. And let's go ahead and assign this expression to large underscore BTC. Okay, let's save it. Let's run it. And oh, the red background chased us all the way to this new table. So let's make it a bit more eye-friendly, okay? We will replace BTC with my table. We will backtrack a little bit. And then instead of specifying a single filter, we will wrap our size filter in a list. And we will copy the product ID equals BTC filter from above. And we will paste it as an additional list item. Beautiful. Now let's save everything and hopefully we fixed the red background. Okay, much better. While at the same time, we are still preserving the red background qualities of the BTC table. Awesome. Good job. Perfect. So now we know how to manipulate data and focus on points of interest. But how can we visualize this data? If it is so dynamic, how on earth are we going to plot it? Well, prepare to get your mind blown, because this is probably easier than Matplotlib or Seaborn. So first, let me show you how it works, and then we will discuss all the inner workings. So for this, we will first need to import a special class. So we will type from deephaven.plot.figure. We will import the class of figure with a capital F. Then in the next line, we will assign the class of figure to a variable name of figure. Go figure. Then right underneath, we will type figure.plot_xy, which means a line graph where the first argument would be the series underscore name we would like to give it. In our case, we'll just assign it to a string of BTC-USD. You can go for any other name. It's entirely up to us. Next, we will specify using the T argument as in table. As you may guess, the table we would like to plot. In our case, that would be btc.reverse. Okay, very important. And the reason is, each time when new data comes in, it is always being added to the top of the table, also known as the head, rather than the bottom, also known as the tail, which is what we usually see. This means that the most recent transaction will always come first. Now, since graphs reflect results over time, if we do not reverse the order of the table we are plotting, our time series will go backwards rather than forward. Some sort of a Benjamin Button situation, which is very nice for Hollywood, but probably not so much for data science. That's why this reverse method is so important. In addition, we will also focus on the few last entries of our table rather than plotting the entire collection of data, which just keeps growing and growing and growing and growing without, any limitations. So let's go ahead and add the tail method to the end of our reverse method. And we've used tail a million times with pandas. We'll just focus on the last 500 entries, or in other words, the most recent 500 timestamps. Now, in addition, we will also specify the column for our x-axis, and in our case, that would be the time column. Right next to it, we will specify the column of our y-axis, which would be the price, of course. We will then wrap everything in a show method, and we will assign this very long expression to BTC_fig, as in Bitcoin figure. And we will do the same for our Ethereum data. We'll just copy the line of code from above. we will paste it right below, and we will adjust each instance of a BTC to ETH. Alrighty, now let's save everything. Let's give it a run. And holy smokes, we are actually plotting dynamic data right on our computer, just like that. We didn't do anything special here. All of those are basic commands, and we didn't even need to deal with missing values, with outliners. We didn't figure out the size of the plot, dividing it by the number of ticks. What am I looking at? Look how quickly those lines are moving. What sorcery is this? Now, so far, we've been exploring both coins independently. But what if we'd like to see how they relate to one another? So for example, we could compare the price of Bitcoin and the price of Ethereum across each and every timestamp. But here's just one problem. Our timestamps are not only measuring days, hours, and minutes, but also seconds and even nanoseconds, which means that the vast majority of our timestamps are unique and therefore incomparable. But don't you worry, we can easily solve this. We will simply restrict the values of our timestamps to minutes at minimum, which will set the nanoseconds and the seconds to 0. For this, we will create a variable storing 1 minute worth of nanoseconds, or in other words, 60 billion nanoseconds. We will call this variable nanos_minute, and we will assign it to 60_000000000. Now, we don't really have to use underscores here. It just makes it a bit more easy to track the number of zeros that way. So let's go ahead and apply it on our Bitcoin data. We will type BTC, and since we don't really need the entire table here, we will only focus on the time and price columns using the select method. So we will add .select, to which we will pass a list with time and price only. Next, we will need to adjust the format of our time column using the update method. So we will add a backslash symbol to the end of this expression, just so it can take us to the next line. And we will add a .update method, and in a string, we will specify the time column, which means that we are updating it in place. We are replacing the original time column with some other values. Now let's go ahead and assign it to a function called lower bin with a capital B. Now this function takes the original data as the first argument, so we will specify time, and as the second argument, it takes in the interval to which we'd like to restrict it to. In our case, nanos_minute. Then lastly, let's assign this expression to BTC_minute, let's call it. Let's quickly fix the indentation of update, just so everything is nice and neat. Make a bit of a gap here. And in addition, let's comment out our figures because we don't want them to pop on the screen again. It's not necessary. Awesome. Let's give it a run. Hopefully everything worked. And perfect. So we did get rid of the seconds and nanoseconds, but the only problem is now we have multiple instances of the exact same timestamp, and all of them have completely different prices, which is not exactly what we were aiming for. So let's go ahead and combine them into a single timestamp that stores the average price. And luckily, we can easily do this using the average by method. So let's go ahead and add a backslash to the end of this expression, navigate to the next line, and we'll add the .avg_by method. Average by. Now, since we'd like to return the average price for each time step, we will specify the time column inside this method. Let's give it a quick save. Let's give it a run. And beautiful! There you go. We are tracking our timestamps by the minute, and each of them returns a single price value. Amazing! We are almost ready to combine this data with our Ethereum equivalent. The only little thing we need to adjust here is we'll need to give a different name to our price column, something a bit more informative, like Bitcoin price. That's why we will add an additional method to the end of this expression with a backslash next line, and we will call the rename underscore columns method. Alrighty? And in our case, we would like to assign the name of BTC underscore price to the existing column of price. Pretty straightforward. Okay, let's give it a run. Hopefully it worked. And beautiful. It did work. So let's go ahead and make a copy of this entire table, and we will do the same for our Ethereum data. We will just replace every instance of BTC with ETH. And now let's go ahead and join both of these tables. So we will first begin with BTC underscore minute, followed by the join method. And as the first argument, which is the table argument, not T this time, table, we will assign it to ETH underscore minute. And the next argument would be the on argument, which represents the mutual column of time. There you go. We can now assign this expression to a new table called combo. And let's have a look. And boom, we got it. So now we have this rough idea of how those coins relate to one another. But rough idea is not exactly what we're looking for in data science, especially when dealing with financial data. We want to be extra precise here. It's our money we're talking about. So let's go ahead and add 2 additional columns to our combo table. And as you remember, we can do this using the update method, just this time we'll do this out of place rather than in place. So in the next line of code, we will type combo.update, to which we will pass a list where the first argument would be the name of the column we would like to create. So the first one would be ETH underscore BTC, and we will assign it to ETH underscore price divided by BTC underscore price. Similarly, we will do the same with our second column. So we will call it BTC underscore ETH, and we will assign it to BTC underscore price divided by ETH underscore price. Then lastly, let's go ahead and reassign this expression back to combo, and let's give it a run. And perfect! Now we know, not just roughly, but precisely, that one Ethereum coin is worth 0.0681 Bitcoin, at least in the most recent timestamp. And we also know that one Bitcoin is worth 14.6843 Ethereum. Amazing! So folks, what we've done here is truly impressive. We've just created our very own cryptocurrency exchange dashboard in almost no time. We've manipulated a bunch of data, we've plotted it, and we even found brand new points of interest within the data. And the best part is, we've done it fast, simply, using plain English commands. Now, cryptocurrency is just one type of data, but there is a vast world of dynamic data out there to explore. So my question to you is, what is your dream real-time data source you've always wanted to work with but never had the technical skills to set up? Maybe you'd like to track the Dow Jones, stock market, maybe some gaming analytics or housing market data, or the number of planes flying in the sky at any given moment of time. I don't know. You tell me. So please leave me a comment below with your dream real-time data, especially if you already have a link to its source. Now, I'll make sure to pass it along to Deephaven, and who knows, they might set up a bunch of brand new quick hooks just for us. Now, the last thing I'm going to mention is that in this tutorial, we've merely scratched the surface of Deephaven. There are plenty of other uses to it, not only in the realm of dynamic data. So, if you find this framework fascinating, please also comment it below. You can even do this on the same comment. I would really appreciate your feedback. Now, thank you so much for watching. I really hope you found this tutorial helpful. And if you did, please give it a huge thumbs up and don't forget to share it with the world. This is the best way you can support this channel and pass your new knowledge to your peers. Now, if you'd like to see more content of this kind, you can always subscribe to my channel and turn on the notification bell. I'll see you very soon in another extraordinary tutorial. In the meanwhile, bye-bye!